Alright, in this video, we're still going over conics, but now we're going over hyperbolas, part 1. I'm breaking this into two parts, just like I did the ellipses. Alright, so hyperbolas, by definition, they are the set of all points whose distance from two central locations, so this point and this point, we'll discuss later what those points are called, from two central locations always subtract, shouldn't have made that plural, whose distance from two central locations always subtracts to give you the same number. Meaning, if I pick the point on this hyperbola, distance d1, if you subtract that from distance d2, which is this point, which is the distance to this point from both central locations, that would equal any other point I picked. So here, d4 minus d3 is going to equal d2 minus d1. That's all that definition means. Kind of like in ellipses, they add it together, but in conics, they subtract. So conics, it's the opposite of ellipses. Alright? So that's your definition of a hyperbola. Alright. Move on. Oh man, my wrist was smearing. Doesn't know the eraser, but it looks like it's smearing it too. Oh, especially down there. Oh, that was wet. Alright, let's keep going. Types of hyperbolas. Alright, you have two types of hyperbolas. You have horizontal, like so. And then you have vertical, like so. Alright, now your center point is going to occur halfway in between the vertex of each parabola. Like if you divided these into two parabolas, your center point is going to occur halfway between your two vertices. Alright, so this is the vertex of this parabola, this is the vertex of this parabola. I know these aren't completely horizontal, but these are supposed to be completely horizontal, just like these are supposed to be completely vertical and the vertices match up. Alright, I know my drawing's a little poor, but completely horizontal, completely vertical. Alright, so this is your horizontal, or this is your left-right. Okay. Now, the distance from your vertex to your center point, when it's horizontal, is going to be your A distance. So just like ellipses, when you divide, it's going to be your A distance. In a vertical, this distance is going to be your B distance. Alright? So now your equation for horizontal hyperbolas is going to be, let me erase types of, I'm going to write it up here. Is going to be x minus h squared over a squared, but instead of plus now, it's going to be minus y minus k squared over b squared equals 1. So as you can see, a horizontal parabola, the only difference between its equation and an ellipse's equation is this is a negative, not a plus. So you subtract the two. Now, if it's horizontal like this is your distance A. Since A comes first, alright, A comes first, which means X comes first, that's how you know it's horizontal, because since X comes first, that's the axis that it mirrors. Alright, so X comes first, so that means it's across the X axis, so it's horizontal. If B comes first, so for your up-down, which is your vertical, your equation, it's going to be backwards. It's going to be y minus k squared over b squared minus x minus h squared over a squared equals 1. So as you can see, how to tell it's horizontal? X comes first. How to tell it's vertical? Y comes first. That's the only way to tell them apart. So now this b distance is the square root of whatever this number is, and this a distance is the square root of whatever that number is. Alright, so that's how you figure out your equation. So let's look at an equation without a graph, and let's fill out our... Alright. Eraser works a little better. Alright, so our equation we're going to use is y minus 1 squared over 25 minus x plus 2 squared over 36 equals 1. I want the center point, the t-axis, which I forgot to say which one that was, x-axis, or the y-axis. And then I want the t-radius. I'm going to get into what this is. Then I want vertex 1 and vertex 2. And that's going to be your coordinate point. Alright, so first let's find our center. Well, you find your center the same way you do for circles and ellipses. X plus 2. We know this is x minus h. Well, since this is plus 2, h has to be a negative 2. And y minus k, since this is a negative 1, we know k has to be 1. So our center is negative 2, 1. Because remember, your x value always goes with x, your y value always goes with y. It doesn't matter that y comes first. All that matters is your x is with your x and your y is with your y. Alright, now your t-axis, or your transverse axis. Alright, for hyperbolas, it's simply whichever one comes first. If y comes first, your t-axis is y. If x comes first, your t-axis is x. So for our equation, since y comes first, our transverse axis, or our t-axis, is the y-axis. Now your t-radius here, if for your x-axis, it would be a. For your y-axis, it's going to be b. So in this case, b squared is 25. So we're going to take the square root of 25, which is 5. Because remember, this is b squared, this is a squared. Since y comes first, our t-axis is our y-axis, and our transverse axis radius is going to be 5 because that's what b is. Alright? Now, so we know now that our hyperbola opens up, down. How do we know? Well, y comes first, so that's how we know it's up, down. We know our center point. I should have drew these a little further apart. We know our center point is negative 2, 1. And we know our t-axis radius
Nathan Holden, your right is waiting.
is b because y comes first. And we know that b equals 5. So now we're ready to find our 2 vertex points. Well, when it opens up, down, they're on a vertical line, so our x's will always be the same. So the x's of our center point and the x's of our vertex, of our vertices, will all three be negative 2 because they're on a straight vertical line. Now, to get the top one, you simply add b to your y, so 5 plus 1 is 6. And to get your lower one, you subtract 5. So 1 minus 5 is negative 4. So, from this equation, we got our center point, which is negative 2, 1. We got our t-axis. Remember, your transverse axis is simply whichever one comes first. Since y comes first, our t-axis is y. Our t-axis radius is simply, it's either A or B, whichever letter goes with your axis. Since it's our y-axis, we know B goes with our y-axis, so it's simply going to be B. So the square root of 25 is 5. Then to find our vertex points, since it's vertical, it's up, down. That means our x's are going to be the same as our center point. And to get our y's, you're simply going to do 1 plus your t radius, and then 1 minus your t radius. All right, so 1 plus 5 is 6, 1 minus 5 is negative 4. All right, so that's pretty much it for Hyperbolas Part 1. So feel free to watch this video as many times as you need to, and be prepared to start working some problems tomorrow. See you tomorrow.